Good morning. When I say inverse, you say, is this a function? Yes or no? Is this a function? Yes or no? Yes, but this function is not. Anyone remember this? Not one to one. See how that helped? Okay, illegal teaching. No, should have let the students discover that all by themselves. Common Core. All right, so definition of functions. Remember, a function, there is no repeating x value. I don't know. There's more complicated definitions. I may be a terrible teacher for simplifying it, but that basically defines what a function is. Just remember what a one-to-one function is. So, trying to slide there. There we go. All right, so I gave a little example, and you can, I'm going to go through this fast because this is all review. And by the way, this book's awesome because if you read their book, they kind of had all this in there. I just kind of structured it in a way that I thought, good, googly moogly. All right, when do I, oh my, I don't know what I hit. I don't even, okay. Now, here's a one-to-one function, x to the third. Okay, you could see x to the third by the picture, and we are going to have to do some picture analysis for what we're going to do here, that you have no repeating y value. Why? Because this graph passes the horizontal line test, right? Then x squared is not a one-to-one. It's a function because it passes the vertical line test, but it fails the horizontal line test. And then you learned what happens when I take the inverse of x squared, y equals x squared. If I take the inverse of y equals x squared and take the full inverse of it, is the inverse a function, yes or no? No, and that's the kind of things that we talked about. So one-to-one, not one-to-one. All right, so again, we just talked about the horizontal line test, determining if a function is one-to-one. And then this is the whole idea of summary of inverse functions. In a one-to-one function, each x value corresponds to one and only one y value. And each y value corresponds to only one x. That makes it a function. If a function is one-to-one, then it has an inverse function. The inverse is a function, right? So these are all things that we need to remember. The domain of f is the range of the inverse. Remember that? That's why the other class says domain and range. Anyone? Exchange. Ooh. All right. Our class, at least, some of you want to be in the other one, but then switch x and y is what I said. Is it any different? Okay, a little bit. But now, here's the one, number 4. Remember that the graph of the original and the graph of the inverse are reflections about the... This is where that came in. Remember that? Okay. So the whole picture is a reflection about the y equals x line. Okay, so we're setting up a lot of stuff that we had to do. And then 5 is how you find inverses. All right, step 1, 2, 3. Okay, not that we're actually going to do that, but I'm just saying. These are all things or terms that we have already done the last 2 years. To allow us to find inverses, and then all those relationships came up. Then we actually did do this last year, specifically for y equals x squared. To find the inverse of y equals x squared, we get the red graph, which is a parabola facing right, which is not a what? Not a function. So what we did last year was we restricted the domain so that the function was one-to-one with the restricted domain, so that when we found the inverse of that restricted domain function, the inverse was a function. We did it. So if I restricted the domain, you could see up here where I'm pointing. I'm pointing right up here. Hey, let's just take y equals x squared for only x's that are greater than or equal to 0. Then all I have is that right side of the parabola, not the one that's crossed off. Now if I find the inverse of this, then I have the red graph that's not crossed off there. The red graph is now a function. And that's what we have required to do. This is what calculus wants. They want functions. Functions are what important, when we're dealing with those. Oh, and by the way, that's interval notation. Feel like we haven't had that in a while. Okay, but that's the other. You could have restricted either way. That's if you had this graph right here, then you'd have this as the inverse. Don't overdo it. What I'm trying to get you to remember is the idea of restricting the domain. Because now what we're going to do is we're going to find inverses or talk about the flat-out inverse functions of trig. So look at these graphs of our three originals. Remember this from chapter 4? Sine is a couple of bulls. Cosine is the cosine kid. And then tangent's like a snake. I don't know. But remember, tangent has its period is pi instead of 2 pi, and then the asymptotes are half the period to the right of the y-axis and to the left, and then you get this increasing snake. But all of them are not, anyone? These three graphs are not one-to-one functions. So what happens when I find the inverse of sine? It will not be a function. So what must we do? Restrict the domain. Now, look at these three pictures. This is what somebody, I'm being honest, what somebody decided would be the best restriction of the domains for each of these three functions. Here's where I'm going to drop a bomb. A bomb in the school. You have to have these restrictions memorized. Okay, so now what might be helpful is to remember the sine bowl. And I'm going to go through how you can maybe memorize this. And this is a lot of setup. We're in rows illegally. Gosh forbid if someone comes in and watches me. I'll be arrested. Okay? For illegal teaching. But look at this. See, if you remember sines the bowl, does this part of the bowl have repeating y values, yes or no? Right? Isn't this repeating y? So I don't want the bowl, and I want my restricted domains to be right around 0 or the y-axis. So if you can just visualize that this is the part of the sine graph that has the positive output values and the negative output values are that part of the graph, then you will remember that sine's restriction for inverse sine, is what I mean to say, is from negative 90 to 90. Because that's when you get all your values from negative 1 to 1 for output values. So then when I take the inverse of that, when I say inverse, you say switch. This will be a squiggly facing up and down, but it will pass the what? The vertical line test. Now, if you can remember, cosine is the cosine what? All right, we're not going to go from negative 90 to 90 because what do we have for y values? Repeating. Come on. All right, repeating. So if I just remember the cosine kid is the cosine kid, positive all the way down to negative, and then stop. Have I covered all of the y values that occur from 0 to pi? You're going to have that memorized. Okay? And then, if you can remember that tangents graph, from negative pi over 2 to pi over 2, or from negative 90 to 90, you get one of those complete snakes. Then after these asymptotes, you get what? Repeating. So if you can just remember that tangents graph goes from negative pi over 2 to pi over 2 for one of its complete snakes, then that is the restrictions for tangent. Now, there is one kick in the stomach. Right? And it is bad. But actually, it's not that bad if you can remember what cotangent's graph looks like. The kick in the stomach is sine's brother or sister is who? Cosecant. Take a guess about cosecant's restrictions. They are the same. So that's not a kick in the stomach, is it? Cosine's brother or sister is who? Secant. And their restrictions are the same. Here's the kick in the stomach. Tangent's restrictions are not the same as cotangent. But what might be helpful is to remember this. Cotan for y equals cotan x. I'm going to sneeze. I lost it. That's so frustrating. It just ruined my day. It doesn't take much. If you remember, y equals cotan of x, the first asymptote starts at the y-axis, and the last asymptote, or the next asymptote, is at pi, and cotangent does what when you graph it? Increase or decrease? So if you can remember cotangent's graph is like this, then you will remember the restrictions for cotan, which are what? 0 to pi. So the only problem is tangents and cotangents restrictions are not the same. So it is a little tougher on the memorization. So what you should memorize is, what does cotangent's graph look like? Why is it different than tangent's restrictions? Okay? Now I'll show you when you do this. And why I say 6.1 is different than 6.2 and 6.3. 6.2 and 6.3 have different types of questions where you don't have to worry about these restrictions. All right? So that's what we have to maybe remember when we get to that next week. Therefore, the domains need to be restricted. So the inverses are functions, because that's what's important no matter what you want to say about it. Here's a table that summarizes the restricted domain values, creating each inverse trig function. This should be used when doing homework tonight, and it has to be anyone memorized. All right, I'm going to pause the video for a second. So out of touch. What am I doing? I don't know. I forget how to do this. Before I show the chart, we need to understand this. And I think you do, but maybe not. I've asked this question with the regulars because they were in chapter 3. We just took their test in 3. When I ask you y equals sine of x, what is x? And I already have it listed here. But the nature of sine, you sign a what? What do you sign? A piece of paper, a document. No, you sign an angle. That makes y a what? A ratio. You better understand this. Yeah. Okay? But when you have y equals sine to the negative first of x, what does x represent? That's a ratio by the nature of inverse sine. So what does that make y? An angle. You better darn understand that, and that's what we're actually doing in this section. Okay, so now we'll go back up to the chart. Oh, and then something else is up there in the chart. Instead of y equals inverse sine of x, you will also see y equals arc sine of x. No crinkle in your eyes. What in the... You just have to understand that that is exactly the same as this. This is just a math thing. Somebody else decided, hey, let's call inverse sine arc sine. I'm just the informant, man. I'm just telling you what you need to know. Okay, so inverse cosecant, arc cosecant of x would be the same question. Okay, so remember what we said about domain and range exchange? Fine. All right, when I graph sine of x, the range used to be from -1 to 1. Now that's the domain of inverse sine. But the domain of the sine of x function was all real numbers, but we have to restrict it. And there's the restrictions. From -pi/2 to pi/2 is what you have to answer inverse sine questions as. All right, that's quadrants 1 and 4. Inverse cosine, 0 to pi, like I stated up there. Notice 0 and pi have brackets on there. Why does inverse tans, -pi/2 to pi/2, have parentheses, not brackets? And the answer to that question is, what is at pi/2 and -pi/2 for tan of x? Asymptotes. So those are undefined values. And there's what I said, tan and cotan do not have the same restrictions. It's because of the graphs, though. I think you can handle that if you remember the graphs of tangent and cotangent like I went through in the notes. This has to be memorized. Okay, and then secant and cosecant. Why are they listed like this for the range and domain? Remember what secant and cosecant's graphs look like. They were, you would graph cosine and then you'd flip the bowls. So if cosine's range was -1 to 1, secant's range was -infinity to -1, union that with 1 to infinity. So hopefully that's a little recollection of that little scenario. But again, notice the restrictions are the same for secant as they are for cosine. With a little blip in the screen, why does it say y cannot equal pi/2? What was that pi/2 for the domain of the secant graph and asymptote. So those are just little added things there that occur with these. And then again, notice the restrictions for cosecant are the same for sine. Okay, so these are all things to help you in your memorization of where I need to answer these questions. What are the restrictions? Okay, and it goes back to those that have knowledge of the graphs. You should be fine. And then, like I said, notice in all these restrictions, if you ever in section 6.1 use a quadrant 3 angle as an answer, you're a silly, silly person. Because quadrant 3 never is, in action here. But, that's what I tell the regulars when we go through this. And they have to memorize it too, so do you. Yesterday, is that bad? I don't know. What does that mean? Because I like salty food, so in my mind, salty sounds great. All right, but anyway, sorry, that's online. Oh yeah, and one more thing. Oh, those regulars, they drive me nuts. We just had the Chapter 3 test today, actually. Chapter 3 test had the pi over 6, pi over 4, pi over 3, right? All right, so you also better be a master of this. And actually, the calculus teachers, many CAT teachers do something different here. They make them memorize a unit circle. I don't do that. What's the 60 in quadrant 2? What's the 60 in quadrant 2 in radians? Oh no, 3 pi over 3 is pi, and then I jump backwards. So it's what? Let's start over. What's the 60 in quadrant 2? I want to know the angle measure in radians. 4 pi over 3 is bigger than 3 pi over 3. 2 pi over 3. Let's start over. What's the 45 in quadrant 3? 5 pi over 4. We're doing radians only. Because you do 4 pi over 4, then you jump forward. What's the 30 in quadrant 4? The 30 in quadrant 4. 11 pi over 6 because it's close to 12 pi over 6. That's the unit circle. That's what you do. It's all fractions. Because the other problem is not knowing those. And those calculus teachers are going to go ballistic on you if you can't do these questions fast. So drawing these triangles are a last-ditch effort. You better know right away that the sine of pi over 6 is what? 1/2. I'm going to jump out that window. Thank goodness I'm on the first floor. Okay? All right. When a question is worded like this, y equals the inverse cosine of -1, or y equals arctan of -1, the restrictions are in action. When we start lesson 6.2, I'll tell you why this is no longer applicable, because we're doing a different type of question. So 6.1 is its own little standalone section. Okay, so what I have to do is worry about the restrictions. I don't know if you want to write them right away or not. Think about the cosine kid. What are the restrictions for where my answer should come from? Where am I at? From what to what? 0 to pi. So restrictions are, I have my little section right here. 0 to pi. Actually, that's the second thing I should worry about. The first thing I should worry about is inverse cosine -1. -1 is a ratio. That's this whole section. And that ratio is actually -1 over 1. And that ratio is x over what? X over what? X over what? X over r. So this is a special little example. What angle has -1 for an x value and 1 for an r value? Not 45. Not 0. Ruh-roh. We better go ahead and draw our little triangle. Or do our little -1 squared plus y squared equals r squared. What does that make y? What does that make y? 0. Where do we get x equals -1, y equals 0, and r equals 1? Finally got it. The answer is pi. I'm stopping the video. Fine. So again, we had a little hiccup on that first one. Didn't get a lot of group responses correct on that. So knowing 30, 45s, and 60s, but also knowing your quadrantals real fast. And the first one that we ran into was a quadrantal, right? Okay, now, arctan. What's arctan mean? Inverse tan. Oh, shucks. I already have it here. But if you remember that tan looks like this, then that covers all possible range values. So when I take the inverse of that, I'll have a function. Okay, so from negative 90 to 90, or what are the radian measures? Negative pi over 2, never mind. Okay, I'm getting nothing out of second hour. Nothing. All right, where do I get negative 1 over 1 for what letters? What letters are those? Okay, again, knowing this is a ratio, this is y over x. Where do you get 1 and 1 for y and x, one of them being negative? Okay, this is a 45. Now, this is what people do all the time. The restrictions say I'm either in quadrant 1 or 4. With a negative ratio, I'm in 4. So they say 7 pi over 4. You're wrong! You know why? This is a number line. Where does negative pi over 2 and pi over 2 land on a number line? From here to here. And this is where your answers need to reside. You know where 7 pi over 4 is? Way over here. So what do I actually have to say the answer is? It's a very, very simple thing you need to do. Negative pi over 4. Go to your calculator. Just take the inverse tan of negative 1. Put your calculator in degrees, though. Your calculator is designed to deal with these restrictions. It doesn't give you 315. What does it give you? Negative 45. So that is why this will be marked wrong every single time. You have to understand this is equivalent to this. The restrictions say the answers need to be between negative pi over 2 to pi over 2. Negative pi over 4 fits under those parameters. Negative 7 pi over 4 does not. I'm sorry, 7 pi over 4 positive. Okay, so that is another thing that's weird about these restrictions. All right, arc sine of negative root 3 over 2. Again, calculus teachers want you to be experts on this. What kind of angle measure gives you a sine that equals a negative root 3, or root 3 over 2? It's a 60. So it's a 60, and then what are my restrictions for sine? So it's actually negative pi over 2 to pi over 2 again, right? So do remember those. This is a 60. All right, so what quadrant am I dealing with? Quadrant 4. You know, or you could draw a triangle. I'm not doing that. I don't think I actually should put that in 3. Determine what you're dealing with. I think in this one, I wanted you to remember that this is y over r. If you needed to draw a triangle, go ahead. It needs to be in quadrant 4, though. What is the 60 in quadrant 4 written appropriately to match these restrictions? Negative pi over 3, not 5 pi over 3. Because negative pi over 3 is in between negative pi over 2 to pi over 2. So this is another weird aspect of this. It just requires a little more added to what you should already know from previous chapters. All right, I kind of left everything here. Arc cotan means inverse cotan. That makes this a ratio. Just if you were at the beginning levels of remembering this, what are those two letters? If it's arc cotan, what letter over what letter? X over y. So if you're in the beginning levels of this, you would draw the triangle. Remember the restrictions for cotan are from 0 to pi. Sorry, I didn't want to do that as a solid line. I want to do that as an asymptote because this is what cotan looks like. From 0 to pi, you get all the range values covered. So that's why the restrictions for cotan are 0 to pi. You draw this. This is a 30. Now, again, number line answer, whatever. What is the 30 in quadrant 2? The 30 in quadrant 2. 5 pi over 6. And 5 pi over 6 does fit in between 0 and pi. So this is a valid answer. All right. What's 2 root 3 over 3? What's 2 root 3 over 3? That is correct. If you don't do that, then you may not associate your sides if you have to draw a triangle. You should, though, in calculus know that 2 root 3 over 3 is one of those special values. But if that helps, that's fine. Arc secant, what letter over what letter? R over See, and then here's what you could remember. Y is always opposite the reference angle. So what's Y? If X is root 3 and R is 2. 1. Y is 1, so that's opposite what? What angle measures opposite 1? 30. That's how you do this fast. Okay, restrictions for secant are the same as the restrictions for cosine. So 0 to pi. But by the way, you never have to worry about the restrictions if the ratio is positive. You're always going to be in what quadrant? 1. 1 always wins. So I don't even care about the restrictions when you have a positive ratio. Okay, so what's the 30 in quadrant 1? Okay, and then give the degree measure. It's the same questions. Instead of degrees or radians, you're going to put them in degrees. Read your stinking directions. Bah. So where do you have a cosine of a negative 1/2? Well, what kind of angle measure? What kind of angle measure is a 1/2? So it's a 60 in what quadrant if the restriction for cosine are 0 to 180? Quadrant 2. What's the 60 in quadrant 2 in degrees? 120. That's what you better be fast with next year or else. Cosecant is negative 2 over, I already wrote it. And if you need to write the letters, fine. It may help you wrong. Okay, and then that should be enough. Y is the side opposite the reference angle. What's my reference angle? It's a 30. So right off the bat, in honors, you should say this is a 30. And then what are my restrictions for cosecant? They're the same as sine. Negative pi over 2 to pi over 2. So what's the 30 in 4 appropriate for these restrictions? What's the 30 in quadrant 4 appropriate for these restrictions? Negative pi over 6. Ah! Negative 30. You just love it when I make a mistake. Boy, they pounce on it like a tiger and catchers. This one's calculators. Okay, now your calculators will do the restrictions. They are designed to do so. No, they won't. This is a kick in the groin. Yeah, I said it. Because what's the restriction? What's the restrictions for tangent? What's the restrictions for tangent? Negative pi over 2 to pi over 2. What's the restrictions for cotan, though? This is where the 84s and any other scientific calculators are kind of jerky for not designing a cotan button for you. Because you will be marked wrong on this question because when I know what inverse cotanning this ratio is. Oh, by the way, do you know that? Do you know that this is a ratio? So if I do 1 over ratio, then I turn it into an inverse tan? This is not 1 over inverse tan of 1.76. That's wrong. You have to change this ratio from x over y to y over x, 84s. And by the way, since 84s have to know this, who else has to know this? Inspires, because you're cheaters with those buttons. So here's what the jerky thing is. When you inverse tan this gives you an angle measure that's negative. When the restriction for cotan is, I'm supposed to get my answer from quadrant what? Starts with a T. 2. So go ahead and inverse tan negative 1 over 1 and tell me what that answer is. Negative 29.5 degrees. That will be wrong because the restrictions for cotan are you have to have a quadrant 2 answer. So this is dumb. This is a calculator problem. This is a calculator design issue because they did not give you a cotan button. But guess what that negative 29.5 degrees is? It's a they just throw our words out. Reference angle. So how do I get the quadrant 2 reference angle? What do I simply do with negative 29.5? Add 180. What is it? Now, inspires, prove it. Use your illegal inverse cotan button. Inverse cotan 1.7670492, very specific decimal, and press enter. Don't you get 150.49? I'm going to start the video again. So you don't have to worry about what we just went through in that last one. And I swear, I know when I teach a long time, some students tune out. I don't have to listen to him. Too cool for school. All right? This first one's easy because we have a sine button. I don't have a secant button, but cosine and secant's restrictions are the same, so I can get that answer just fine. Read the directions. They want this one in radians. I am going to go back, though, and say that you will be marked wrong if you write negative 29.5 degrees for a question like number 52. And it is a calculator problem. They are the ones that have created this problem by not giving you a cotan button. So you better star this example and understand that it's only when I'm dealing with tan and cotan that there are tricky issues because of my invalid calculator. And that's really true. I don't know why they don't put these buttons on your calculator. Because at this point, they put them on the Inspires, so they should be on all of them. Okay, now these are weird. Okay, then look at what it says up here. And you guys got to know this from now on, forever. I think forever. What does it say right there? What's the word I'm pointing at? Exact. What does that imply? I almost fumbled this. No what? No calculator, no decimals, possibly. Answers in radical form, but it really means no calculator. So by the way, this ratio is positive, so we're fine. But what you have to understand is I arc cosine a ratio, and I get a what out of that? Angle. And then they want me to sine this angle, which gives me a what as a final answer? A ratio. So the final answer is going to be a ratio. So how do I get this without a calculator? I draw a triangle for theta. So you have to understand, when I arc cosine this, I get theta. And then I sine theta, the same triangle, same angle, and I get the ratio off of that same triangle. So draw the stinking thing. Where did I get root 15 from? Okay, what? Pythagorean theorem. That was me, not you. Pythagorean theorem. Okay, then what's the sine of this angle measure? Now I go back to this, and the answer is what? Theta. Ay, caramba. What's the sine of theta? You'll get one. Root 15 over 4. Okay, and then just for giggles, this is where this whole restriction thing gets crazy. What time is it, by the way? Oh, I'm doing great. Remember this used to happen all the time in Algebra 2? All the way to the bell. Samuel is blabbering. Okay, just for giggles. See it? Okay, now I can ask this because there's nothing about restrictions. I can cosine any angle I want. What's the cosine of 7 pi over 4? What's the cosine of 7 pi over 4? Root 2 over 2. Now I arc sine that. What's the arc sine of root 2 over 2? Restrictions! 45 degree in what quadrant? You'll get one. It's a positive stinking ratio, so it's what? So what's the answer? 45 degrees. Or, it depends if it's radians or degrees. So what I'm trying to tell you is, you cosine 7 pi over 4, but then when you arc sine root 2 over 2, you got to worry about the restrictions and answer the question according to the restrictions when you're dealing with arc sine. And then this gets real weird. What about arc cosine cosine? Don't you think arc cosine cosine should cancel each other out? Yeah, but it doesn't. The answer is not 4 pi over 3 because of restrictions. What's the cosine of 4 pi over 3? Oh, your calculus teacher's going to scream at you. It's a 60 in quadrant 3. Hike. Someone said quadrant 5, for gosh sakes. It's quadrant 3. So what is this ratio? Positive or negative? But then, what's the arc cosine of a negative 1/2? The restrictions are from 0 to pi on arc cosine. So the answer to this is... Oh my. All I'm looking for is the quadrant 2 over 3. And I quit. So again, arc cosine cosine doesn't just cancel each other out. You have to worry about restrictions. And it looks like we have a lot of work on knowing what sine, cosine, and tangent of these angle measures are. So yeah.